What are submarines? What is their mere use? A vessel with independent underwater operation is a submarine. It contrasts from a submersible, which has less capabilities for diving underwater. In the past and now, the phrase has also been used to describe small or medium-sized ships like the midget submarine and the wet sub, as well as remotely controlled vehicles and robots. Welcome back to Just Tech. In today's video, we are going to see how extremely the submarines work. For more details, continue watching the whole video without skipping. Before getting into the video, subscribe to our channel for more such amazing content. Although there had already been some experimental submarines created, the design of submarines really took off in the 19th century. They have since been adopted by numerous navies, both big and small, but were initially deployed extensively during World War I. In addition to protecting aircraft carriers, blockade running, nuclear deterrence, reconnaissance, conventional land attack, for instance using a cruise missile, and covert insertion of special forces, military uses of submarines include attacking enemy surface ships, merchant and military, or other submarines. A wide range of missions, including anti-surface and anti-submarine warfare, information gathering, mine reconnaissance, ground strikes, and guarding other fleet ships, can be carried out by American submarines. These submarine cruisers become the most potent weapons since they are able to launch nuclear warheads underwater with a weapon system that can burn the entire continent to the ground. The Typhoon-class submarine, which is what we are investigating today, can house 160 crew members in excellent living quarters. Typhoon-class submarines have 5 inner hulls, 2 of which are the 2 primary long-pressure hulls, and can stay down for 120 days under normal conditions and maybe longer if necessary. Each pressure hull has 10 compartments for a total of 20 compartments, which house the crew work area, restroom, kitchen, gym, reactor compartment, turbine chamber, and all other living facilities. To manufacture breathing oxygen on a submarine, there are 2 methods. The first method uses electrolysis, and the device that does this is known as an automated electrolytic oxygen generator. These hydrogen and oxygen gases are then pumped into these pressurized tanks. A submarine may float like other ships because the weight of the water it moves is equivalent to the weight of the ship. This implies that the pressure exerted by the submarine on the water is equal to the pressure exerted by the water on the ship. We refer to this phenomenon as buoyant force. A rubber duck floating in your bathtub, a pirate ship at sea, or a submarine all use buoyant force in the same way. The submarine has unique tanks that can be filled with air or water to regulate buoyancy. Due to this, the submarine is less dense than the surrounding water, which causes it to float to the surface. These devices produce more than 4,000 liters of oxygen per hour, which is periodically released throughout the day at predetermined levels. Burning candles made of chlorate is the second way to generate oxygen. This is a chlorate candle, which is a cylindrical chemical oxygen generator made of a combination of 2 main chemicals, sodium chlorate and iron powder. This backup method, which requires no electricity or other external power source because the solid oxygen candle is in a very small volume, can be used if they ever lose power for whatever reason. The submarine sinks because it becomes denser than the surrounding water as a result. Air is always available on board to top off and refill the tanks. In an emergency, high-pressure air can be pumped into the tanks to quickly bring the crew and the ship up to the surface. Although it may sound exciting to live on a submarine, there are difficulties in living underwater. The 3 major issues are keeping the temperature, fresh water supply, and air quality. With that, we come to the middle of this clip. We are now seeing the amazing technology of submarines and how they manage to work on all times. It might stun us at times, and also it is interesting to know about how it works. For more such amazing information, subscribe to our channel and continue watching the rest of this clip for the rest of its details. 4 gases, nitrogen, oxygen, argon, and carbon dioxide, make up the air we breathe. Our bodies consume all of the oxygen when we breathe deeply. Carbon dioxide is exhaled when we exhale. With nitrogen and argon, we don't do anything. To fill and top off the tanks, an air supply is kept on board. While living on a submarine may sound like fun, there are difficulties in this environment. Maintaining the temperature, a fresh water supply, and air quality are the three key issues. Next, carbon dioxide must be expelled because it can otherwise become toxic. Carbon dioxide is captured from the air using soda lime by devices referred to as scrubbers. Finally, in order to avoid condensation on the inside of the ship or equipment, exhaled moisture from breathing must be eliminated. Dehumidifiers are used to do this. Submarines must find a way to keep a fresh water supply on hand for drinking. Submarines can virtually be used in psychological warfare because an adversary can never be certain whether one is lurking off its beach. Although many nations have submarines, the most potent and frequently the biggest of these vessels are those that can launch ballistic missiles with nuclear bombs. American submarines of the Ohio class are reported to have a maximum depth capability of 800 feet. They actually think they can go a lot further, but as soon as a sub surfaces, their stealth is compromised, particularly in the modern era of satellite tracking. Submarines must therefore be able to submerge for extended periods of time in order to go unnoticed from one side of the planet to the other. There are always submarines deployed thanks to the scheduling of the various submarine patrols. Despite this extended patrol length, submarines are known to have the best cuisine of any ship, at least in the U.S. Navy. Some claim that this is the case because submarines are so small that the cook has nowhere to run if a meal is subpar. Submarines receive a larger food budget than other vessels, thus that is more likely to be the cause. The most junior sailors will have to share bunks aboard smaller submarines, where there is no real personal space and one sailor will have to work while the other sleeps. Submarines have less access to outside contact than many surface naval ships. A unique email account is provided to each submariner so that their families can contact them. All of these messages are then sent electronically once the submarine can receive communications. A dedicated crew member reviews each message on board. Because their transmitters are often too small to rely on VLF frequencies, submarines must surface to shallow depths where they may respond using antennas that protrude from the water. Modern submarines frequently use this depth to quickly transmit with satellites in order to download and upload data. VLF radio makes up the majority of communications with the majority of submarines, with a few other less prevalent approaches, some new technologies under development, and some alternative systems created for usage when the primary systems are damaged. What is effective underwater is that while sonar allows a submarine to map out its surroundings by essentially producing a sound and then listening to when and how the sound returns, generating this sound makes it relatively simple for others to locate a submarine. Submarines are therefore unable to deploy active sonar when operating under cover of darkness. Instead, they rely on inertial navigation. With that, we come to the end of this episode. If you enjoyed the video, like, share, and subscribe to our channel for more such amazing information. Also, bang the bell icon for notification. Watch other videos from our playlists too. Bye!